In this video, we are going to discuss trigonometry PYQ questions. Question: if sin alpha is equal to root 3 by 2 and cos beta is equal to root 3 by 2, then tan alpha into tan beta. Options are given here. A is root 3, B is 1 by root 3, C is 1, D is 0. Solution: sin alpha is equal to root 3 by 2. So we know that in the trigonometric values table, so sin we get root 3 by 2 value for sin is 60 degrees. So here this implies sin alpha is equal to root 3 by 2 can be written as sin 60 degrees. So from this we get alpha is equal to 60 degrees. So here sin alpha is equal to root 3 by 2. This implies sin alpha is equal to root 3 by 2 in terms of sin is sin 60 degrees, we have root 3 by 2. So that implies here alpha is equal to 60 degrees. Similarly, here given cos beta is equal to also root 3 by 2. So this implies so cos beta is equal to, so here in terms of cos, root 3 by 2 is cos 30 degrees. We get cos 30 is equal to root 3 by 2. So we have cos 30 is equal to root 3 by 2. Now cos beta is equal to cos 30. From this we get beta is equal to 30 degrees. We get beta is equal to 30 degrees. Alpha is equal to 60 degrees. But what we have to find here? So tan alpha into tan beta. So tan alpha into tan beta value we have to find. We know that alpha is 60 and beta is 30. So therefore tan alpha into tan beta is equal to tan alpha into tan beta is equal to tan alpha is replaced by 60 degrees here. So tan 60 into tan beta is tan 30 degrees. So tan 30 degrees. So which is equal to tan 60, we know the value of tan 60 is root 3. Tan 60 value is root 3 into tan 30 value is 1 by root 3. Tan 30 value is 1 by root 3. Now root 3 gets cancelled. We get, so which is equal to 1. So therefore the value of tan alpha into tan beta, is equal to 1. So see the options here. So we have the option C is 1. So that's why final answer is here. C, option C, that is 1. So therefore the value of tan alpha into tan beta is equal to 1. So this is very important question already given in the CBS examinations. So now next question is, suppose here given cos squared theta by sin squared theta, here cos squared theta by sin squared theta minus, so 1 by sin squared theta, so is so simple form of this is. So simple form of this is, so out of the given options, so here option A is given tan squared theta, so option B is given here secant squared theta, option C is given here 1, option D is minus 1. See what is given here, cos squared theta by sin squared theta minus 1 by sin squared theta. So what is the simplest form of, means what is the simplest form of this cos squared theta by sin squared theta minus 1 by sin squared theta. So now to solve that, here in the solution, so cos squared theta by sin squared theta, minus 1 by sin squared theta. So now here if you observe here, cos squared theta by sin squared theta minus 1 by sin squared theta, both denominators are same here. So sin squared theta, Here if you take the LCM is sin square theta we have here. LCM is sin square theta. So when you take the LCM, here denominators are same, no? So we can add the numerators. So that's why we get in the numerator, so cos square theta minus 1. So what is the value of cos square theta minus 1? So we have the identity sin square theta plus cos square theta is equal to 1. We have the identity sin square theta plus cos square theta is equal to 1. Here we have to get cos square theta minus 1. So cos square theta minus 1 means from this cos square theta, here already left hand side we have cos square theta and this plus 1 if you write left side this becomes minus 1. So cos square theta minus 1. So if you write this in sin square theta to the right side, which becomes minus sin square theta. So that's why clearly we can write cos square theta minus 1. Cos square theta minus 1 is equal to minus sin square theta. So that's why here this cos square theta minus 1 is replaced by minus sin square theta whole divided by here denominator sin square theta. See here sin square theta by sin square theta. So both are same ratios gets cancelled. So which is equal to minus 1. So that's why therefore cos square theta by sin square theta minus 1 by sin square theta value is minus 1. Now see the options here. We have tan square theta, secant square theta. So C is 1 and D is minus 1. So that's why the correct option is minus 1. So these are all very important problems. Already in the previous years it was repeated, right? So that's why you have to practice carefully, then you get the solutions are also very nicely. So that's why we can solve further problems are also same like this. So similarly here, so other question also, so these are all given in the previous year's examinations. So we can if you practice perfectly, you will get the good marks in the examinations also. So that's why similar models you may get in the coming examinations. Now further here, we can, further question we can discuss that if theta is if theta is an acute angle of a right angle triangle, then which of the following equation is true? Then which of the following equation is true? So options are given here. So first option is given here, sin theta into cot theta, sin theta into cot theta is equal to cos theta is given. And the second one is given here, cos theta into tan theta, cos theta into tan theta is equal to sin theta is given, sin theta. And third one is given here, cosecant square theta minus cot square theta is equal to 1. And fourth option is given here, tan square theta minus secant square theta is equal to 1. See here, out of these four options, which of the following equation is true we have to, is not true, suppose, is not true. So which of the following equation is not true, we have to verify. So now here I am taking the first option. Suppose here option A is sin theta into cot theta, so is equal to sin theta into cot theta is equal to. Here if you take a right angle triangle, suppose like this, suppose this is a right angle triangle. So A, B, C, we know that this is a right angle triangle. Here if you take, it is a right angle triangle at C. Now if you take here theta, now this is a, theta is an acute angle. Here sin theta into cot theta is given. We know that sin theta, writing as it is, we know that cot theta is cos theta by sin theta. Cot theta is cos theta by sin theta. So that's why sin theta is gets cancelled. So we are getting here cos theta. So that's why here option A is given. So sin theta into cot theta is equal to cos theta. So that's why we get, which is also is equal to cos theta. So that's why option A is true. We get the same result. So similarly, suppose if you take the second option, cos theta into tan theta, cos theta into tan theta. So cos theta into tan theta, which we have to get, that is sin theta. So similarly here also cos theta I am writing as it is into tan theta. Tan theta is writing as sin theta by cos theta. This is sin theta by cos theta. Now cos theta gets cancelled. So which is equal to sin theta. See the option B also. Here we have cos theta into tan theta. That is also we have to get sin theta. So that's why here option B is also true. Option B is also true here. Similarly, if you take the option C now if you take option C we have cosecant square theta here, cosecant square theta minus cot square theta. Taking cosecant square theta minus cot square theta, and cosecant square theta we know that which is reciprocal of sine. So we can write this is 1 by sine square theta. We can write 1 by sine square theta, and minus cot square theta can be written as cos square theta by sine square theta. Cos square theta by sine square theta. See, observe here, sine square theta denominator is same for both the fractions. So we can take here, we can take the LCM, that is sine square theta. So sine square theta is LCM. So in the numerator we get 1 minus cos square theta. See, already we know that sine square theta plus cos square theta is equal to 1. See, observe here, sine square theta plus cos square theta is equal to 1. We have the identity. So from this numerator, if you see that 1 minus cos square theta, so from this sine square theta is equal to, we can write 1 minus cos square theta. Sine square theta is equal to 1 minus cos square theta. So that's why here 1 minus cos square theta in the numerator is replaced by sine square theta, and by in the denominator is also sine square theta. Sine square theta gets cancelled. Both are same trigonometric ratios. So that's why if you see the option C is also we are getting cosecant square theta minus cot square theta is equal to 1. So that's why option C is also true. Option A is also true. Option B is also true. So we can say that option D is not true. But also verifying here, option D is given what? Tan square theta minus secant square theta, given option C in the left hand side. Option D in the left hand side, tan square theta minus secant square theta. So further, this tan square theta is also writing as sin square theta by cos square theta minus this secant square theta can be written as 1 by cos square theta. Now if you see that here we can take the LCM, that is cos square theta. So cos square theta is LCM. Now here sin square theta minus 1 we get in the numerator. Sin square theta minus 1 in the numerator. So from the same identity we have sin square theta plus cos square theta is equal to 1. We have the identity. From this sin square theta minus 1, sin square theta minus 1, so which is equal to, see, minus 1 means this 1 if you write in the left hand side it becomes minus 1, and this cos square theta if you send right side it becomes minus cos square theta. So that's why here in the numerator this sin square theta minus 1 is replaced by minus cos square theta by cos square theta. So that's why if you observe that, so cos square theta is same trigonometric ratios, both are gets cancelled, so minus 1. So that's why if you see that in the option D, tan square theta minus secant square theta is equal to 1 is given, but we get tan square theta minus secant square theta is minus 1. So that's why this is option D is wrong. So option D is not true. Option D is not true. So like this, by using the identities, we can verify that these options, we can say that clearly which is true and which is not true also, right? So like this, so we can simplify that, but you must be perfect in the identities. If you are perfect in the identities, then we can simplify, we can solve these type of questions very easily. So that's why, so the three identities, sin square theta plus cos square theta is equal to 1, and so secant square theta minus tan square theta is equal to 1, or 1 plus tan square theta is equal to secant square theta, or third identity is, so 1 plus cot square theta 1 plus cot square theta is equal to cosecant square theta. Like this we can remember the identities. And also suppose here the next question is given cos power 4a minus sin power 4a on simplification so forgives on simplification forgives here the options are given 2 sin square a minus 1, this is option A, and option B is given, so 2 sin square a plus 1, and option C is given 2 cos square a plus 1, and option D is given 2 cos square a minus 1. See, out of these 4 options, we have to verify that. So, which is true? Which gives this is a simple form of a cos power 4a minus sin power 4a. In the solution, see, taking this cos power 4a minus sin power 4a. Cos power 4a minus sin power 4a. So, this cos power 4a can be written as, so cos square a whole square minus, so sin power 4a can be written as sin square a whole square. See, we can write, so cos power 4a as cos square a whole square minus sin power 4a can be written as sin square a whole square. So further we get, suppose if you see, this is in the form of, suppose if you treat this cos square a is a small a and sin square a is small b, so which is in the form of like a square minus b square. So we know that a square minus b square formula is a minus b into a plus b. A minus b into a plus b or a plus b into a minus b. So here a is cos square a and b is sin square a. So this can be written as in the form of a minus b into a plus b. So a minus b means cos square a minus sin square a. Cos square a minus sin square a into a plus b can be written as cos square a plus sin square a. Cos square a plus sin square a. But we know the identity here. We know the identity cos square a plus sin square a is equal to 1. We know the identity cos square a plus sin square a is equal to 1. So this cos square a plus sin square a is replaced by 1. And here, if you observe that, we can write here, so this is cos square a writing as it is, minus this sin square a can be written as from this sin square a is equal to 1 minus cos square a. So sin square a can be written as 1 minus cos square a. So that's why here sin square a is replaced by 1 minus cos square a. So now it becomes, so here cos square a minus 1 and minus into minus is becomes plus cos square a. So into 1, so that is you get same thing only into 1. So which is equal to here cos square a plus cos square a, which is 2 cos square a, 2 cos square a and minus 1. See, observe the given options here. So first option is 2 sin square a minus 1. Second option is 2 sin square a plus 1. So third option is 2 cos square a plus 1. So fourth option, option D is 2 cos square a minus 1. So option D is correct option. So the simplest form of cos power 4a minus sin power 4a is 2 cos square a minus 1.